Hello. So in this video, I'll be going through all the circle theorems that you need to know for the IGCSE maths exam. So the first one we have is, I'd say, one of the ones that students forget the most. It's the alternate segment theorem. It states that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. So the angle that lies between a tangent and chord, so let's say we have any tangent. This is the tangent that they've drawn here. And the chord is any straight line that touches 2 points of the circle. And so we have this chord right here, AC. And then this angle that lies between a tangent and a chord, that angle is equal to the angle in the alternate segment. So what that means, the angle in the alternate segment it's also subtended by the same chord AC. You can see that what makes up this angle ABC is made up. The most important part of the angle ABC is this chord AC, the length of the chord AC. So if AC was a bit longer, the angle ABC would be larger. So therefore, with the given chord and its length, the angle ABC is subtended by this chord AC. The angle ABC is subtended by the chord AC. It's the defining point of the angle, since these 2 points from the chord come off to point B. These 2 points from the chord meet at B, which is at the circle. So that's why it's subtended by the chord. So therefore, what it's saying is that this angle right here, ABC, is equal to this angle here. That's subtended by that lies between a tangent and the chord. So for the next one, we have the angle at the center is twice the angle at the circumference. Which means this is a pretty simple one. If you have an angle here, it lies on the circumference. The point A lies in the circumference. And then if we have an angle with the legs coming off the same 2 other points. So D and B are fixed points. These are fixed. Well, we have 2 different pairs of legs coming off D and B. In this first case, they meet at the circumference. And in the second case, they meet at the center of the circle. So this angle DAB is half of the angle DCB. That's what this theorem is. So the angle at the center, the angle at the center is angle DCB. That's twice the angle DAB. So now, this actually ties in with the angle in a semicircle theorem, though it may not seem like it. It says that the angle in a semicircle is 90 degrees. So when we have the diameter, AB, as the hypotenuse of a right angle triangle, the angle right here, opposite the hypotenuse, is always 90 degrees. And it ties into this angle at the center theorem because the angle at the center in this case is this right here. And we know that this is 180 degrees since it's the diameter of the circle and it's one straight line. Therefore, that's 180 degrees. And as we can see, this is 90 degrees right here. Angle ACB is 90 degrees. And as you can see, the angle at the center here, 180, is indeed twice the angle at the semicircle, which is 90 degrees. So that's a way I would remember these two. They're interlinked. So now the next one is angles in the same segment theorem. So same segment, what it means by the same segment is that we have a fixed chord, let's say DB, but we have 2 different pairs of lines intersecting, touching the circumference of the circle. And it's important to note that the points A and C must be lie on the same segment, on the circumference of the segment. So if you can see, these 2 points both lie on the major arc DB, the major arc. So for example, if one of them was, if let's say A was here instead, then this theorem wouldn't hold true, because now A is on the minor arc DB, minor arc. The minor arc is always smaller than the major arc. So therefore they must be on the same side of in the same segment, which, and by being in the same segment, they mean being on the same arc, either the major arc or the minor arc. And now we can see that what I was talking about here, where one is on the major arc and one is on the minor arc, ties in with the next one here, cyclic quadrilateral. It's when all 4 points of a quadrilateral are inscribed within the triangle, within the circle, and they're all touching the circumference, and the opposite angles add up to 180 degrees. So in this case, if we moved A over here to this minor arc DB right here, then we would have that this angle, this green angle, plus this angle right here would add up to 180 degrees. So now we have the situation where they're on the opposite side. We have one being on the major arc and one on the minor arc. So when that's the case, the opposite angles, the A and C, add up to 180. And similarly, the angles here at D and B also add up to 180. So now this is the final one you need to know for IGCSE. We have tangents of a circle. So a tangent is a line which touches the circle at only one point A. It touches at just one point A. So, and if you draw the radius from A to the center of the circle, you get this line AB, and that's always going to be perpendicular, which means it meets at 90 degrees to the tangent. So that's this A done, the first part that you need to know for tangents. And secondly, we have the in the second diagram, we have tangents that meet at an external point of the circle. So you can see these two tangents right here, AD and AB, both meet at this external point A, which is outside the circle. So from the point D and from the point B, this length right here, let's call that x centimeters, is gonna be equal to this length right here, which is also x centimeters. So the tangents which meet at the same point, so in this case it's point A, are equal in length here. They both are x centimeters. So yeah, that's all these circle theorems that you need to know. If you want to see me implementing it in one of my other videos, please click this card up here. And other than that, that's it for this video. Thank you very much for watching.